Day 5, and we just did some practice with angles, but now we're switching gears and we're looking at the giant inch, which all of you have in your folders. And we use this for whenever we are measuring something with a ruler, or I put at all of your desks little mini tape measures. Like this, see? Now, let me freeze this for a second because I think, I might not have put a tape measure at yours. Everybody has one of these now. So what we're looking at specifically here is this is like a zoomed in picture of the space on your ruler between 0 and 1. It's like a super zoomed in. So if you grab a ruler and look, you'll notice that in between 0 and 1, there's all these little notches. Now, these notches are all different lengths. We have some that are really tiny. These are our 1/16 of an inch. Then we have some that are just a little bit bigger. Those are our 1/8. And then we have some that are even bigger still, right above that inch. That's our 4ths here and there. And then finally, we have a line in the middle, right in between 0 and 1, and that's our 1/2 inch. So the way we use this, I like to have this guide here because sometimes maybe we forget exactly how it works. If I were to measure a line, for example, let's say it's not exactly 1 inch or exactly 2 inches. Pull out this paper that I also gave you. We're going to look at the second line, number 2.
No, number 2.
Yeah, number 2. I'm going to start with something that's more than an inch. If I put my ruler up against this, first of all, should I start it where the edge of my ruler is up against the edge of the line, or should I start it where the 0 line is up against the edge?
The edge is accounted for it. No, where your line starts, right there.
Yep.
On these, though, it counts for it.
Yeah, you're right. On the tape measure, it'll be a little different. We'll start with the ruler just because it's easier to see. Then we'll move to the tape measure because you'll use that in a more real life situation.
Yeah.
But let's say we're measuring something tiny like this, and it's nice that these are see-through.
Oh, yeah.
You want to line up that first line. And they do it like this because, these rulers could get banged up. You don't know if that's going to be exactly the start. So we start on that line just before 0. And we're going to see how long this line is. Now, it's longer than an inch.
Not quite 2.
Not quite 2. So we want to kind of move this around and see which little dash mark does it actually land on.
15, 16?
Yes, it's right on that little tick mark just before 2. Now, you're right, it's 15/16. If you ever forget, though, you can go back to your giant inch paper and see here is the line before the inch, 15/16. So, how long is this line segment?
1 15/16 of an inch?
That's right. 1 and we say 15/16. And you can write IN with a dot, or you can use 2 dashes. That means inches as well. 2 little dashes. And there it is. We just measured it. Now we can pull out our tape measure, see how accurate it is. Sometimes these tape measures, you see how there's like a little metal tip at the beginning? Depending on where it was manufactured. Now, these were bought in bulk, so they may not be as accurate.
It's pretty
Sometimes,
close.
Yeah, that's good if it's close.
Oh,
Sometimes you may have to just start after the 1 inch and go from that first clear line you can see to get it real accurate.
About dead on.
Let's see. It looks like it's pretty accurate.
Yeah.
It's pretty accurate. you can tell that here is my 2-inch mark,
Yeah.
and it touches the dash right before the 2. So again, that would be 15/16. Good. Good.
Yeah.
Now let's look at number 1. We'll go backwards now. We'll line this up. And I'm noticing I like to use my 1/2 inch as a bit of a marker as well. And then we see how many spaces away from the 1/2 inch am I?
2.
2. So,
5/8.
yeah, there it is, 5/8. 1/2, I go over 2 spaces, 5/8. So how long is this line segment number 1?
5/8 of an inch.
That's it, 5/8 of an inch. Perfect. Perfect.
So you put a little too long.
Yep, 2 little dashes. Or I guess what would that be? Like a quotation mark almost?
Half a
Half of a quote.
half a quote.
Look at number 3. Number 3 looking like 3.
3.
Yeah, right on the dot. 3 inches, perfect. So, if it's just a nice whole measure, we just put the 3 and the dashes. 3 inches. Very nice. Now, in the real world, you're probably not going to be measuring little things like this unless you're trying to measure, for example, maybe I want to see how thick the molding is around the room. Maybe I want to replace a portion of that molding. Maybe I broke it. This is where your tape measure might be nice.
Looks like
You can
3/4.
hook it on and then see where it lands. Are you looking at number 4 now?
Yeah.
And let's see.
I'm getting ahead.
Yeah, 3/4 of an inch. Good. Good. Okay. So what I'm gonna have y'all do now is try to get through 5 through 10. I'm gonna set a little timer here, and then we'll go over what the correct measurements are. I just want to see if y'all can practice being really accurate and getting the correct fractions on there as well. Use that giant inch if it helps. We'll come back. I'll pause this. Okay, that was our 5 minutes. Let's see. What did we get for number 5?
1 3/16.
1 3/16. Anybody get something different? Okay, 1 and 1 2 3/16. Perfect. 5 is 1 3/16 of an inch. Okay, how about number 6?
1 9/16.
1 and you said 9/16.
Yeah.
Anybody get something different?
Which one were you on?
Number 6.
Hang on.
We've got 1. This is 1/16. Add 2. There's 3/16. Add 2. I think that might be 5/16.
We're at.
That's what you got? What'd you get, Lacey?
I did not understand what we were doing. I was not picking up.
Oh, that's okay. We're measuring
Six.
these little line segments here. So we've got starting at 0. We go over. It's more than 1 inch. Now we're gonna count these little tick marks. We have 1, 2, 3, 4, 5.
You're right.
So 5
Yeah.
16ths.
Oh, where that? Oh, I'm looking at the wrong. 2 past the 1/2 inch, I guess.
Oh, so we're just counting the lines after it?
Yeah, that's all you gotta do.
okay.
Just count the
I
lines.
was like, I don't understand what's going on.
Yeah, we just count the lines. So here, we'll do it again for number 7.
Or 2.
1 inch, and you said, yep, 2 dashes past it. So what would that be?
360.
So we start, this is like our 0,
Oh,
1, 2. So what would it be?
I got it. 108.
1 and 1/8.
okay.
Good. 1 and 1/8 inch. Number 8.
1 and 13/16.
13/16. So check it. 1. There's more than 1. If it's too many to count up to 13, sometimes
I
like
counted
to say,
backwards from the 2.
yeah, I say, okay, here's 2. There's 1, 2, 3 away from 2. So I go over here. Here's my end. 1, 2, 3 away. So 13/16. So that's 1 and 13/16. Good. How about number 9?
Yeah.
This one now?
Yeah, half inch.
You guys got that too?
Yeah.
Perfect. 1/2 inch. Let's look at number 10.
2 and 15/16.
Got 3.
So if we lined it up, if it was a 3, you can see it's a little bit away from that 0. We want to make sure that's really nice and lined up. It's just shy of 3. You gotta be so careful with them. We've got 1 here, 2 here. Here's my 3. How many spaces away from 3?
Yeah, put them away.
Just 1 space. So what would that be? 1 space away. 15/16. Good. And then we had 2 inches and that 15/16. Not quite to 3. 2 15/16. Okay. We look at a few on the back. We'll practice. Look at 11. I'm gonna line it up right on there.
2 and 1/8 of an inch.
So we have 2 right here. 1 space, 2 spaces away from 2. And if we check here, 1 space would be 1/16. 2 spaces would be 1/8. So 2 and 1/8. Of an inch. All right, so moving to that review packet, it says Unit 1 review day 5. You're gonna see on the second page, there are some multiple choice questions. I'm not gonna ask you this on your quiz. This is just extra information that, is good to know, but you're not gonna be quizzed over it, so don't worry about this section on page 2. But starting at the beginning, this is the kind of stuff you can expect to see on your quiz. We have the segment addition postulate, which is where we take the 2 smaller segments, add them together, and they're always equal to that larger segment that's at the bottom. Sometimes that larger segment has an X in it. That's okay. You still set it up the exact same way. Let's see. Why don't we just start with that? So for number 1, I have a line segment labeled BCD. I'm trying to solve for X. Do we have any ideas of what we could do to set up a problem and solve for x here.
But 5x minus 3 plus 3x minus 2 equals 19.
Yes, yes. 5x minus 3 plus 3x minus 2 equals 19. A line to keep myself organized.
Combine like terms.
Mm-hmm. What am I combining?
I want to, I guess, add 2 to the -3. Or, no.
They're on the same side of the equal sign. We do the same thing that the sign before it tells us to do. If they're on opposite sides of the equal sign, that's when we do the opposite. So if
So,
go ahead.
how's that?
No, go ahead. What are you thinking? You're good.
Just subtract 2 and subtract it from the 3 as well.
Yeah, yeah. We've got -3, -2. We can think of it as -3 minus 2, or we could think of it as -3 plus -2. We're adding those together, right?
Yeah.
What's that going to give us?
-5.
-5. What else can we combine?
Or 5x and 3x.
Yeah. 5x, 3x. What do we get?
8x.
8x. X minus 5
Equals 19.
equals 19. Good.
Now add 5 to
Mhm.
both sides.
Good. Add 5 to both sides. Equals what?
24.
24.
Divide 8.
Good. Right. X equals 3. Good. Very good.
Yeah. With the head, yeah.
Okay.
It's the combining.
Look at number 2. Don't let the fact that the whole length has an X in it throw you off. We're still using this picture to help us first. What are my 2 smaller segments?
2x plus 22 and your 3.
Perfect. So those get added together. What equation can I write?
2x plus 22 plus 3 equals x plus 17.
Yes, 2x plus 22 plus 3 equals x plus 17. Right off the bat, if we just look at one side of the equation, do I have any like terms?
Yeah.
I do. What do I have?
Your 3 and 22.
Perfect. So what happens when I put those together?
You get 25.
25. Okay, bring everything down. we should have 2x plus 25 equals x plus 17. Do I have any other like terms
Yeah.
on this side of the equation?
No.
No. What about just the other side?
No.
No. So if there's nothing we can combine on opposite sides there, or on the same side, I mean, that's when we start having to actually cancel things and move them around,
Yeah.
doing the opposite. So what could I do now?
Subtract 17 from both sides.
We could, yeah. Minus 17. Minus 17. And is that
2x plus 8 equals x.
and a 2x plus 8 equals x. Now what?
We can combine our x's.
Yeah. How should we do that?
1x and 2x is 3x.
Are they on the same side of the equal sign?
No.
No, so I can't just add them, right?
Oh, subtract.
Yeah.
Subtract the 1x from 2x gives us 1x.
Okay, so if I do this, let's do minus x on both sides. If we've been careful, we need to know that what's left over here? 0. Bring down my 8. 2x minus x is x. What can I do now?
Subtract 8.
Subtract 8. There's other steps we could have taken to solve this, but the way that we did it works just fine. This is correct. 0 minus 8, we get x equals negative 8. Now I'll show you my line of thinking, what I think I might have done, which this is absolutely correct. This works just fine. But whenever I get to 2x plus 25 equals x plus 17, when I get down to this, usually my first thought is, I want to get the x's together right away.
Yeah.
So I probably would have done minus x first, which we eventually did over here, so it's okay. And then I would have had x plus 25 equals 17. And then what would I have done?
Just one more.
Yeah.
2 steps.
Oh, I
Subtract
got
your 17.
So if I subtract 17, I'll have 0 over here. Which I can do. What's a faster way, though?
12.
If I got rid of 25, I would
Yeah.
have x by itself then.
Yeah.
So I would do it that way. I'd get x equals negative 8.
Here you go.
So this way works. And if
Just
you
more
subtract the
steps.
17, that works too. But if you can think about in your head, like, what's going to happen when I take this step? Well, if I get rid of 17, I have nothing left over here but 0. Then I would have to move stuff back over again.
Yeah.
And that's what happened here. I had x by itself here, and I got rid of it, and then I had 0. Then I had to move the 8 back over here. And I still got the right answer though, so it works. You can do it both ways. Just don't get frustrated if you have a 0. You're allowed to have 0. Just means you got to keep going. We still don't have x by itself yet, but we did it. We did it. I feel like you guys are pretty good about setting the equations up. We could probably practice a little more with just equations in general, just solving them and getting real comfortable. And I'll give you guys some stuff later on for that. Any questions or discussion points for segment addition postulate? Or do we want to move on?
Yeah.
All right. So the next one is using a protractor and a ruler to draw an angle. So protractor, that's your half circle thing. This guy. The reason I'm having you draw an angle today is to get used to knowing whether we use the inside numbers or the outside numbers for measuring. So if this is my starting point and line that is extending out, so we have like a ray here. My my protractor needs to be lined up with the
On that
point
line.
on that circle, yep. And then line it up there. Now these protractors are not 100% accurate. They're just a little bit off. But we can make a general idea.
Do we use the inside 20?
So let's see, do we? If I want to draw a 20-degree angle, let's think about how 90 is like that perfect corner.
Yeah.
Is 20 less than 90 or more than 90?
Less.
It's less. So the angle I draw better be smaller than 90.
Yeah.
So
Be the inside
we're
angle.
going to use that inside 20 because that's going to give us a little angle. If
Yeah.
I use the outside 20, that's going to give me a big angle. That'll be more like 160 degrees. So what I'm doing here is I'm just going to mark about where that 20 is. And if it's hard to mark it inside, you can follow that line out. Make a little mark there. I'm just going to connect this point to the little guides we've given ourselves. That. So I know when the angle opens this way to the right, the opening to the right, whether that be here, whether it be even bigger, it could even be a really big angle like that. When the flat side is on the right, we use the inside numbers. It's like these numbers inside.
So when it's on the left side of the 90,
Yeah.
then you use the outside numbers?
Yes. So let's do that as well. If I have, we'll give ourselves a new starting line. I'm gonna draw a line like this. That's a little bigger than 3 inches. I'm gonna put the point over here and make it facing the left this time. If I wanted to draw that same angle, that 20-degree angle,
Same spot pretty much, is the different side.
yeah, it's going to be the exact same size. It's just oriented differently. So we can see here, we're starting at 0 degrees. As it opens and gets bigger, now we're at 10 degrees. Now we're at 20 degrees.
That's cool.
Yeah,
Is that called something different?
Nope, it's the same. It's just a different direction. Just a different direction. If it does have a different name, I'm not aware of it, but if I ever hear it, I'll let you know.
Do we have to make our little swoopy mark on this?
You don't have to, but you can. The art. Can. I'll do it.
I didn't know if you wanted us to do the vertex and
Yeah, I know what you mean. For the constructions.
oh yeah, that's
Yes.
what the thanks. Thank you, Tim. I'm excited for that again.
Yeah, we'll be doing some of those today. So, if it's open to the right, we use the inside numbers. If it's open to the left, we use the outside numbers. So, if you want to make a note of that, you can. Opening to the left outside numbers. And that would be like, do it on the outside. Now, on your quiz, you're going to be asked to measure an angle. So you won't have to actually draw it and be real precise. It'll be a question kind of like, there'll be an angle already drawn. You'll use your protractor, you'll line it up, and it'll say, what is the measure of this angle to the nearest tenth, or to the nearest like 10 degree? So if it was like between 18 and 20 or something, you can say 20 and it'd be fine. It'll be multiple choice, so it'll be really obvious. Okay. Does anybody still need to see this page before we flip to the next? Bless you. So we have one more of those just for more practice, but this time it's a larger angle. This is 145 degrees. Go ahead and put an arrow at the end of that ray. Are we going to use the inside or the outside numbers?
Assuming it's gonna be the inside still, but it's gonna be wider.
Yep, it is going to be a wider angle because it's a larger measure. We're still going to use the inside
Yeah,
numbers because it's starting at the right.
just running big mouth frogs.
So 145 degrees. Here I am at 140. Here's 150. We'll just go somewhere in between. It doesn't have to be perfect. We'll just put a little mark somewhere in the middle. I mean, that's actually not great. Somewhere there. And we'll just connect those. 145-degree angle. I know the bell's gonna ring here in a minute. Okay.
We didn't really go over the acute and obtuse.
No, we didn't. This is not gonna be on your.
Oh, is that what
This
you
is
said to
just
mark out?
Extra, yeah. We don't have to worry about 5 through 8. These are not gonna be on your quiz.
Okay.
But you know, if you're curious, we'll go through it. But that was the bell. I'm gonna give you guys a little break. I'm thinking we can probably pause it.
Okay.
Okay, we are back from our break. And what I just said before I started the video is we're actually gonna take a break from this packet and we're gonna review how we do our constructions. And what we're gonna do to review those is we're going to use these angles that we've drawn. Let's actually just start with the one of number 4. This 145-degree angle. And we are going to construct an angle bisector. So we need our compasses and some sort of straight edge. That could be a ruler, it could be a protractor, just a straight edge. And then we also, if you find it helpful, and you know, sometimes we forget the steps, we did take some more detailed notes on the angle bisector. On
Yeah, I was
day
gonna say we
3.
see a plus.
Yeah. On day 3, we took some notes on the angle bisector. It was the 3rd page of our notes. And we made this little step-by-step guide. So if any of you missed this day, this would be a really great thing to go back and watch and have in your notes, just in case you forget. We do, of course, also have that handout that has all the construction steps, but I find this a little bit easier to follow. So, step 1 we're gonna start with the point of our compass on the vertex, which is right here. And then we're gonna draw an arc through the angle. So let's do that. I'm gonna start with my point, and I wanna draw an arc that is touching both edges of my angle somewhere. So I don't want it to be open too big that it goes past. Like, let's see if where mine is works.
Where you want it at? About
Just anywhere that it touches both.
like 2 inches, I guess.
Yeah, let's see where mine is. I have mine open to 1.75-ish, like 1 3/4 inch maybe. I would maybe do it smaller. And again, the obtuse angles, these large, big angles, can be harder to draw that full arc on. So something that I like to give as a tip, I've said it before, but I'll say it again. When you're putting your pressure on the point of your compass and laying your pencil down, sometimes it's easier to move the paper instead of the pencil.
You ain't lying.
Do that. And notice, I think my compass is a little loose because it moved a little. You may need to get a different one here soon. Figure out how to tighten it. My mark is actually further in.
Mine went
Make mine bigger.
over.
Easy.
You're not hungry. You're
You
not.
ever gotta start over, don't be ashamed. I'm starting
Not
over
Jalen
myself
when
right
you're
now.
hungry.
Okay. So I'm gonna make mine a little smaller because that big one was giving me trouble. And have it open to like one. And here. My paper is stuck to the table with a sticky note. I'm gonna lose it. Try again. If you're
You got
struggling,
it.
you're not the only one.
You got it.
Okay, here we go. See, there's this sticky note again. Okay.
Yeah.
There we go.
Yeah.
Okay, so I have an arc. And let's mark the point where the arc touches the edge of our angle. So here's a point. Here's a point. Once you've got that set, give me a thumbs up so I know you're ready. Got it? Got it. Good. Okay, so that was step 1. Step 2 says put the point on the intersection from step 1. So that's those 2 points we just marked.
Here.
And draw an arc inside the angle. We do this twice, 1 for each intersection point. So you can keep your compass open at the same size. You can make it smaller, you can make it bigger. You may have to just play around and see what is going to allow the 2 arcs to touch each other. With an angle that's open real big like this, sometimes it's better to keep it a little bigger. I just want to make sure that my pencil is going past the vertex. That's how you know it's going to cross. So I'm going to make an arc.
Mine's inside my arc though.
And that's okay. Mine is too. Arc here. Now I'm going to flip around, put my point on the other intersection. Make sure your compass is open the same size.
We draw a line down.
And make another arc inside. And sure enough, look at that, they cross. Once you have that intersection, mark your point. Sure, if you marked it in the right spot. A way to be sure is you can take your compass and measure put it back on that point on the edge here and see, is this pencil touching the intersection from both sides? It is. So if it's not, that means you may want to go back and redo your arcs.
Oh, it's a touchy.
Good. Thumbs up when you guys have step 2 done, this little cross in the middle. Don't need to rush.
See, it's perfect color.
I already tried with another class to put those pins in here. Couldn't get it to stay.
That ain't working, huh?
Too big. Need help with step 2, or does anyone want me to check?
I'm just confused, I think.
Okay, let me see your paper.
I erased it, 'cause I was doing something wrong.
You're okay. Okay, everybody's got it up to here. So once you have that little X in the middle, this is where we draw the final line that creates our angle bisector. So for step 3, in my notes it says draw a line from the
Hey.
vertex. Oh.
Trying to shut it down?
Yeah, let me get it trying to shut down. Draw a line from the vertex through the third intersection, so that little X.
Uh-huh.
So that means we're going to take a straight edge, line it up with the middle of that X, that intersection, and your vertex. Draw a line going through. And now we have our angle split in half. And then finally, to show that these are the same size angle, we can put an arc in both of our smaller angles. And that is the final step. Now, if this felt harder than the last time we did it, it's because these large angles are way harder to do this on. Way harder. It's easier on a smaller angle. So, once you've got that labeled, let's flip over to one of these 20-degree angles and try it with that
Huh?
on the first page.
Oh, okay.
What I'm going to do is I'm going to do the left-facing one just because I made it bigger. And I'm going to erase that arc I put in the middle.
We can do them to left facing ones too?
You can do it to any way facing. You can do it if it's facing up, facing down. Just move your paper and whichever way is easiest. Like if I have my angle open like this feels awkward to hold my hand like that. So I'm gonna do it so that my point is facing away from me. You know?
Yeah.
However is more comfortable. So step 1, same. Put the pointy part of your compass on the vertex and create an arc that goes through the angle like that. And we're going to mark those 2 places where we cross the edge of the angle. So that would be here, here. These 2 points. These 2 points are where the point of my compass goes next. I'm just going to keep my compass open exactly the same size. Put it right here on that point and draw an arc inside the angle. I'll switch sides on the other side and begin. This time we came up with more of like a flat X. We
Yeah.
have such a skinny angle. And if we have that intersection, all we need to do is connect the vertex have it go right through the center of that X. If it helps to mark exactly where that center is, do that. Be as accurate as you can, but we're doing what we can with the tools we have. They're not perfect. It's okay if it's not perfect, but we should be able to get it pretty close.
We got it.
And then how do I mark that these angles are equal?
Put a couple little angles in there.
Yeah, put a couple
One.
little in there.
Uh-huh.
That's it. There we go.
We turn it into a decrepit spider web as well.
It does look like a spider web,
Little bit.
except for maybe they would go that way.
Yeah, maybe they go to the other way. There, look how pretty.
Yeah, a
that
little
is.
spider web.
There you go. Little shade
Okay.
there, shade there.
There we go. Okay. So if anybody wants more practice on these or with anything we've been doing, I have so many extra papers I can make copies of. Just don't be afraid to ask me. I will give you what you need. What I'd like for us to practice next though is that perpendicular bisector. And we do have one more type of construction. So you can do it on a separate paper if you want. You can do it somewhere on this packet if you want it to all be in one space.
How about this handy dandy exit ticket?
Yeah, well, I can't do it for you, so.
No, I'm gonna do it on that one.
You can, if you want. You absolutely can. If you're wanting to just get that part done. I'm gonna
So I'm gonna do it on
do it. Do it. I'm gonna just grab a notebook here and I'm gonna draw a line that is, let's do 4 inches. Yeah, 4 inches. 0 to 4. Mark those endpoints.
We gotta have our straight line though to be perpendicular, don't we?
Well, we're gonna construct that. We'll start with just a line. We don't want to draw the perpendicular line until
Oh, yeah,
we've
that's
done
right,
our
yeah.
markings.
Yeah, that's right.
Yeah. So this is the one where we have to be careful about how big our compass is opened up. Does anybody remember what size we need to have it open to relative to the original line?
About either just under half or just a tad over half.
Which one?
Just a tad over.
Just a tad over half.
That way,
Why can we not do
because you
under?
gotta have that little center opening to it.
Yes, yes. So I'm going to show you guys real quick. If I don't have my compass open big enough, this is what's going to happen. I start on my point,
Be too fat.
I make an arc, I go to the other point, I make an arc. These won't ever touch each other. It's too small. We need these to be open bigger so that they cross.
Yeah.
So I know halfway is somewhere-ish here. I'm going to go point here and I'm going to go more than half. It doesn't even have to just be a tiny bit more than half. It can be a lot more than half if you want. It just, I don't think that it would be good if it was bigger than the line. I think it's better if you keep it about 2/3 to 3/4. So these markings, don't use them. We're going to start here, make an arc. Okay. Here's my first one. When I go to make my second arc, where does my point go next?
On the other one.
On the other one. The other what?
Other end dot.
Yeah, the other end dot, end point. And we need to make another arc. Now, once you have your first arc, if you want to cut corners a little bit, this is actually fine. You don't have to draw a whole nother giant arc. You could just show it'll intersect here, it'll intersect there.
Oh, you cheater.
As long as your compass doesn't move, because watch, if I did draw the big arc, that's where it's gonna go anyway.
Oh, yeah.
Just need the intersections. And in fact, whenever it comes to construction workers and stuff, you're not hardly ever gonna see the full arcs. You're usually only gonna see the X's.
I got the whole eyeball in there.
Well, that's good. So I have these. What is my final step to drawing that perpendicular bisector?
Your line through it,
Now,
up and down, vertical line.
where does that line need to pass through?
Your intersections and your main line.
So on the line, at my straight edge as close as I can to those little X's. And I'm gonna draw all that through. Just like that. Now there's a few things I need to label on here.
You named your 90.
Need my 90. How do I show that this is
Box.
90 degree?
Box. Right angle box there.
Hmm?
And then tick mark on each side of your eyeball.
That's to show.
And an X and a Y.
Yeah, well, you could do that. You don't have to. You don't have to do an X and a Y.
That's
You can. You can.
She did. Okay, thanks.
All right, now, that was a little demonstration. If y'all want, I can come around and check to see how things are looking, and if you have questions one-on-one, I want to make sure those get answered. So let me pause this real quick. Okay, so we've done some construction. Let's go back to the packet. Here was that little bonus section, 5 through 8. We've got 4 different angle types. I haven't explicitly taught them to you, but it is a fact that one day, sometime someone may talk about these. I don't know, depending on what setting you're in. But each of these types of angles we can describe in a certain kind of way. There's an acute angle, a right angle, an obtuse angle, or a straight angle. So the way that we can describe all of these is an acute angle is a small angle because it's cute. It's small. It's a cute angle. That's how I remember it. An acute angle is an angle that's less than 90 degrees.
So, less than 90.
Less than 90. That's acute. So that would be like that, if you wanted to draw a little picture. A right angle is exactly 90. So that's what we were talking about with a perpendicular bisector creates a 90-degree angle, which is a right angle. So that is exactly 90 degrees. And that looks like that corner with the box in it. Any ideas on an obtuse angle? What that might be?
Would that be the backwards
Backwards. What's that?
facing?
Backward facing? You have the right idea. Less
Kind
than 90, exactly 90. What would the other option be?
of over 90.
Over 90.
Well, that's what I mean by a
obtuse-
wider.
Yes, a wider angle. So it's bigger, more than 90. More than 90. And that would be like, I see what you mean by backwards. I guess good and back.
No, I'm just backwards thinking.
Now a straight angle is exactly what it sounds like.
Just straight.
It's a straight line. It is 180 degrees.
It'd be up and down diagonal anyway.
Yep. So a straight line is what a straight angle is, and it looks like this 180 degrees.
Okay.
Now, an obtuse, let me specify. If it's 180 degrees. Technically, yes, that's more than 90. But when it's exactly 180, we don't call it obtuse. We call it straight.
Straight.
Yeah. So, number 5, what kind of angle would this be?
It looks straight to me.
Yeah, that's a straight angle. Then circle option C. How about 6?
And it looks like it would be actually,
Obtuse.
Obtuse.
yeah, obtuse.
Yeah.
More than 90.
Sometimes it helps if you mark the vertex and then draw your little arc. Gives you a little visual. This is more than 90. It's obtuse. It's not quite straight though. How about 7?
It's right.
Where's the
Oh
bottom?
no, wait. Less than 90. Acute.
This is less than 90?
No. Obtuse again.
Yes, this is obtuse. Obtuse again. It's just facing a different way.
And then 8.
8 is a tricky one. What they didn't give you is the most important detail is that box in there.
It's still 90.
Yeah, that's a right angle. It's 90 degrees. On a quiz or something in the future, I would not do this to you. I wouldn't make you guess. You would know there would be a box in there.
Okay.
So you'll know. Okay, so that's just a little extra material for fun. Okay, so going on, page 3, number 9 and 10, we have these parallel lines and angle relationships here. So we have 2 options when we're looking at these types of angles. They can either be equal to each other. So I'll write like A equals B. Or you can add them together and they equal 180.
I think these are equal.
Number 9,
Yeah.
they are equal. Good.
9 plus 10x equals 59.
Yes. If I were to look at the position of them, I know that the ones that are across from each other are equal, same position. These are really just across from each other here. So I can say, you said 9 plus 10x
Yeah.
equals 59. That's right.
Subtract 9
Good.
from each side of the thing.
Mm-hmm.
Gives us 10x equals 50.
Perfect.
And then divide 10 on each side.
10. And
X equals 5.
5. Good. Good. Okay, number 10. Sometimes these ones that are real close together are a little trickier to see. So let me draw
Wouldn't that be 18x plus 8 plus 16x plus 2
What's the rest?
equals 180?
Yes. Yes, yes, yes. So we can, if we wanted to, we could draw those little circles, fill in my opposite angles. And I see if they were the same color, they'd be equal, but these are not. They're different. So we add them up to 180. I'm going to write that equation. You said 18x plus 8 plus 16x plus 2 equals 180. I'm going to draw my line.
Don't we combine
Mm-hmm.
our terms?
Yep. What do you want to combine?
Then you say be easier to do the x's first?
Yeah, let's do that.
So, are we at taking away 16 from 18
If
or
they're
adding?
on opposite sides, we take away. If they're on the same side,
We add
just put them together.
So 16 and 18.
Mm-hmm.
What is it? 34?
Yeah, 34. You're right. 34x.
4a plus 8 plus 2. Well, 82 is 10.
Perfect. So let's put those.
34x plus 10 equals 180.
Good. Now what?
Now we can subtract 10 from 180.
Good.
It's 170.
Perfect.
34x equals 70.
All right. What's our last step?
Divide
Yes.
34 on both sides.
Equals.
170 divided by 34. 5. X equals 5.
Good. X equals 5.
These again.
Yeah. Almost there, y'all.
These are alright though.
Now
These ain't bad.
these don't take too long.
No.
Before we move on to number 11, anybody need more time? You good? Okay. All right, 11. Find the midpoint of the line segment with the given endpoints. So we need midpoint formula.
X1, Y1, X2, Y2.
Yep, we're going to use that as our labels. X1, Y1, X2, Y2. And I have found that it helps me if I like circle the X's. Just so I know if they're circled, they're together. If they're not, they're together. What's my formula for this?
It is negative. Okay, so it's -3 minus 7.
What's the formula?
Hang on. X1 minus X2 plus, or squared.
That's distance. Where's midpoint? It was a couple days before that.
Wow.
You're good. You're good. We're looking for the one that looks like a big coordinate.
X1 plus X2
Good.
over 2
Yep.
and Y1 plus Y2 over 2.
Good. You got it. Okay, that's our formula. So now let's plug stuff in.
Alright, so -3 plus 7 over 2.
Perfect.
And 10 plus -5 over 2.
Perfect.
Plug in our values and yeah, do the math.
Do the math.
-3 plus 7 is 4
Good.
over 2 down. And then 10 plus -5. 10 plus -5 is 5
Good.
over 2. Simplify it, right?
Uh-huh.
4 over 2
Yep.
and then comma 2.5.
Excellent. That is our midpoint. Good.
2 comma 2.5.
Perfect, perfect, perfect. All right. Ready for distance?
The what?
Distance is going to be next.
I was ready for that just now, I guess.
Okay. Distance. You got that formula for me?
Yeah.
What is it?
X1 minus X2 squared plus y1 minus y2 squared, and then square rooted.
Yes. Now, what is the rule about whenever we square a number?
Well, first thing I'm seeing is the x1 minus x. Never mind. Oh, wait. Never mind. No, I am right. Hang on. Okay, so if we got a minus next to a
Uh-huh.
negative number, then it turns it positive, don't it?
You're right. You're right.
Okay.
So
We're gonna have that.
You're saying that 7 minus -5 is going to turn into 7 plus 5.
Plus 5, yeah.
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 You're right. You're right. Plus. Let's see. What's going to go in my y parentheses?
That's gonna be -5, minus -6, but it's gonna be +6.
Good. -5 plus 6. Now, I was asking you a minute ago about the rule when you square a number. No matter what, whether what's in parentheses is a positive number or if it's a negative number, anytime I square any number, what is the sign of that answer always going to be? Is it always going to be positive or always going to be negative? Positive. The reason is because if I square something, I'm taking that number times itself. So if I have a negative number and I square it, like -2 squared, that means -2 times -2. Those negatives will cancel every single time. So anytime you're doing distance formula, you will not have a negative number at the next step. If your calculator tells you a negative number, it is wrong.
So should I use the parentheses and do parentheses 7 plus 5 parentheses squared if I'm
Hey.
typing it in?
I would do 7 plus 5, bring that down, and then square that.
Okay.
I wouldn't do it all at once just because it gives you more opportunity to make an error.
So then 12 squared.
Yep, 12 squared.
$144.
Okay, so we're going to have that.
And 5 plus 6 is 1, and then 1 squared. 1 squared is 1.
Yep.
So 13 squared, I guess. 12 squared. Hang on, 12 squared.
You got that a minute ago. 12 squared instead of 144.
Yeah, 144, and then 145.
There,
Plus
145.
Well, we got to square root that.
Yes, we do. You will get a crazy decimal, and that's fine.
So square root 145, right?
Mm-hmm.
145, and then second square root, or wait, square root and then 145.
Yeah.
So square root 145.
So that in case anybody's watching.
12.04.
Second button, and then x squared gives you your square root. 145. Enter. Yep, you're right.
12.04.
Perfect. That's our distance.
Distance equals 12.
All right. Now,
Bonus.
bonus. This is the last thing. Your bonus will be similar to this. I'm gonna mark the angles that are being labeled here because it's kind of hard to tell. These two and those two.
Okay.
For number 13, I know it looks crazy, but can you tell how those angles are related?
They're, I guess, what? vertical from each other.
Yeah. So what's that mean about their measurements?
They're not equal to each other, or they're equal to each other.
Which one?
Not equal.
They're not equal.
Well, no, they are equal, I guess.
So remember, if they're vertical,
Uh-huh.
it's like a mirror image.
Yeah,
They're
So they're-
opposites. They're looking at each other in
Yeah.
the mirror. These are equal.
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 So 16x plus 7 plus 17x minus 1.
You're saying they're equal, right?
Yeah.
So we don't
Oh,
need to add them.
17x plus 7 equal 17x minus 1.
Equal, good. 17x minus 1. Okay. Now, these x's to be on the same side.
Yeah.
So what should we do?
Combine.
Combine them. How?
Add 'em.
They on the same side?
Okay, subtract them.
Yeah.
Subtract 16 from the 17.
Yes. Yes. Minus 16x on both sides.
That eliminates the 16x.
Mm-hmm.
Gives us 1x.
Does it? Look at what I wrote up here. See what we're doing? We're getting rid of the x's over here,
Uh-huh.
bringing them all over there. So, oh, were you saying this is
Yeah,
1x?
minus 1x.
I'm sorry.
That's
You're right.
1x.
You're right. I thought you meant this would have 1x.
No.
You're right. My bad.
7 equals, yeah, x minus 1.
Okay, last step.
And then, do we,
Plus 1. Yeah. We want x by itself, so we want to get rid of anything that's keeping it from being by itself, right?
add 1,
Yep, add 1.
8
8.
equals x.
Perfect. All right. All right, all right. One more. One more. And then
No.
you go.
No, can't do it.
They're equal. Good. These are also vertical angles. Don't let all those other crazy lines confuse you. They're across from each other, so they're equal. What is a good equation I could write?
12x plus 5 equals 11.
Perfect. 12x plus 5 equals 11x plus 15.
Minus 11.
Yes, let's subtract 11x. Keeps us with x plus 5 equals 15. Minus 5, that's it. Good. X equals
10.
10. Beautiful. Okay, y'all. Proud of you guys for hanging in there. Some drilling today. Good. Okay. Get out of here. You already did your exit ticket. Also, I mean, you're welcome to stay. If you have questions or need help with anything, please don't feel like you're being kicked out. But tomorrow will be a shorter day because we're doing the practice quiz. If you missed that, there will be a video up. But I would, definitely do it because it's 22 minutes.
I'm gonna be here.
See y'all tomorrow.
I don't know.